At 2:51 a.m. on the 17th of January 1991, an F-117 Nighthawk stealth fighter of the US Air Force dropped the first bomb of the Gulf War. The laser-guided weapon destroyed half of the Iraqi Air Defense Center at Naqayab and ushered in a new era of air warfare. Stealth is one of the key military developments of the 20th century. Stealth aircraft have shown their ability to attack undetected and have thus changed the way the future conflicts will be fought. The idea of reducing vulnerability in warfare has been around for centuries. Only very recently, however, has the technology become available which makes aircraft invisible to radars a reality. Radar works by transmitting a beam of electromagnetic energy. When a conventional aircraft flies into the beam, it reflects some of that energy back to the transmitter. The more reflective the target, the larger the proportion of energy reflected, and the greater the distance at which it can be detected. From its earliest successful use at the start of World War II, radar has provided advance warning of air attacks. But it can also be used to guide anti-aircraft artillery and missiles. During the Vietnam War, hundreds of US aircraft were shot down by radar-guided missiles and radar-directed guns. Reducing an aircraft invisible to radar has long been a dream of designers. Such an aircraft could attack by night with complete surprise. For long years, it was only a dream. Today, the dream has become a reality. Aircraft like the F-117 Nighthawk, V-2 Spirit, and YF-22 are a new generation of warplanes. The first service aircraft, which had stealth characteristics built in, was the astonishing Lockheed SR-71 Blackbird spy plane. Built for the CIA in the 1960s, the Blackbird was primarily a speed machine. Stealth was only a secondary characteristic. An aircraft's almost important characteristic for radar detection is its radar cross-section. Careful shaping plays a crucial role in determining an aircraft's RCS. Avoiding angles in construction, particularly right angles, reduces radar reflectiveness. Flowing lines with the fuselage blending into the wing and engines buried deep within the structure all help to reduce RCS. The Blackbird's primarily means of defense was not stealth, but its incredible performance. For over 25 years, this allowed it to gather reconnaissance on the most sensitive targets with almost absolute impunity. Along with shape, radar absorbent material, or RAM, is the other critically important component of stealth. Painted or polished metal is a good reflector of radar energy. RAM, by contrast, absorbs radar energy like a sponge, converting it to heat instead of reflecting it. A ferromagnetic resin surface layer absorbs high-frequency radar waves. A honeycomb core absorbs lower frequencies. The first truly operational stealth aircraft was the F-117. This is constructed of many small flat surfaces or facets. These reflect incoming radar energy in all directions. It doesn't make the aircraft invisible. Some energy will be reflected back to the radar transmitter in an irregular manner. All the defenses see is an almost imperceptible sparkling return, which doesn't give away the position of the aircraft and is far too weak to allow a missile to lock onto it. Large targets will usually reflect more energy. A truck has an RCS much greater than a Boeing 747 airliner or a B-52 bomber. Later bomber designs, like the B-1B, have become more stealthy, a process culminating in the amazing F-117, which has an RCS the size of a small bird. The F-117 has revolutionized air warfare. The most heavily protected targets have no defense against aircraft which cannot be detected by radar. Since becoming operational in 1983, it has become the US Air Force's most important precision attack weapon. Known as Blackjet, or the stealth fighter, the F-117 was one of the star performers during Desert Storm. It demolished key targets in Baghdad and elsewhere, undetected and unharmed by Iraq's defenses. The Northrop B-2 Spirit advanced technology bomber is the biggest stealth aircraft yet. It's intended to fly long-range strategic missions. Designed a decade after the F-117, the B-2 includes many of the earlier stealth features in a smooth, blended flying wing shape of much greater efficiency. A flying wing design also avoids the sharp joints which are a major cause of radar reflections. America could have had a stealth bomber in service in the 1950s if the XB-49 flying wing had been successful. Its smooth, slender shape meant that it was very hard to detect on radar, at least from the front. But technical difficulties meant that it never replaced the massive strategic bombers of the day. Northrop had to wait nearly another 50 years before its flying wing design was finally accepted. By coincidence, the B-2 shares exactly the same wingspan as its XB-49 forebear. During Desert Storm, the coalition deployed hundreds of strike aircraft to attack particular targets. These had to fly fast and low to avoid defenses. They were usually escorted by a similar number of defense suppression aircraft, as well as fighters, electronic jammers, and a large tanker force. Much of their attention was on the Iraqi defenses instead of the mission, since they had to watch for missiles or anti-aircraft artillery.
Bulldog, Crush 03.
Crush 03, go ahead.
Crush 03, airborne as flagged on the Delaware 120 at 10.
Crush, stand by, unable to give you radar advisories.
A single stealth fighter could attack with more precision and less risk. Stealth aircraft did not need to fly low to avoid radar. They had more time to detect their targets and make their attacks. A stealth mission might take days of planning and preparation. With the battle plan worked out, the armament technicians make any last-minute alterations to the weapons load. Last-minute intelligence data could mean a change of weapons. Finally, in the hours before takeoff, weapons will be loaded and fused. The stealth fighter is given its final signature check. One badly fitting panel might double the F-117's radar signature, so every panel must fit correctly. The air crews will see pictures of their targets, hopefully very recent satellite photography, giving precise aiming points for the laser bombs. One bomb in the right place is worth 100 which miss, so planners try to make surgical strikes. They will try to determine the best approach to the target. Even though the F-117 is the only aircraft that has the luxury of being able to safely loiter over a target area, its pilots will still plan their attack runs to avoid missile sites and fighter airfields. Stealth fighters generally fly individually by night. The only support requirement is on long-range missions when a tanker might be necessary.
the first aircraft to go in and actually drop ordnance. We arrived within seconds of the beginning of the war. Baghdad was lit up. They obviously didn't know we were coming. They weren't expecting us. And the first series of bombs that we dropped to take out their communications network came as almost a total surprise. From then on, trips into the Baghdad area and some of the larger airfields were almost always met with fairly intense AAA fire. Normally, the aircraft would get into the target unobserved, drop its bombs, and then be shot at on the way out. Because we were able to get in there unobserved, I think that helped us avoid a majority of the AAA and helped allow for the fact that we never did get hit by so much as a bullet.
The results were quite remarkable. The F-117 attacked and destroyed key strategic targets.
The F-117 consisted of roughly 3% of the total number of aircraft used within the theater of operations, and yet we were able to strike some 40 to 45% of the strategic pinpoint targets that were hit during the war. But even I was amazed at how well we did in combat. We flew almost 2,000 missions against some of the most highly defended targets in Iraq, and the aircraft performed superbly. Not only were we able to put ordnance directly on target where we needed it, but the aircraft came away without so much as a scrape. The technology worked, the accuracy of the systems worked, and the pilots were able to really knock out some tough targets with amazing accuracy.
Stealth is an epoch-making technology. Along with gunpowder, the machine gun, and the aeroplane itself, it is one of the few concepts which have genuinely changed the face of warfare. Before the advent of the stealth fighter, a large part of a pilot's attention was on survival. In a stealthy aircraft, the flyer can concentrate much more effectively on the job in hand, delivering weapons with an accuracy never before achieved.
Stealth technology has proven itself to be a force multiplier. It allows you to get either closer to your target or to your target unobserved. And basically in an air-to-air combat, or whether it's an air-to-ground, the guy who can get in closest, the guy who can get the first shot, is normally the guy who wins.
Stealth technology has changed the way future wars will be fought. By making aircraft invisible to radar, it gives the advantage back to the attacker. He can choose exactly where and when he wants to strike. Stealth aircraft are the warplanes of the 21st century.